I'm here with Rich Vondrak, the project scientist for LRO. And Rich, you're going to explain to me a little bit about the LRO spacecraft and tell me what this is going to do here.
Okay.
So this is LRO in all its deployed glory, right?
Mm-hmm.
This kind of square shape is to fit a lot inside, right?
That's right. The inside here is a large propulsion tank. The LRO spacecraft with fuel weighs about 2 tons, but the spacecraft without the fuel, before it's fueled, weighs only about 1 ton. So it's like having an automobile where your automobile has as much gasoline in it as the whole weight of your car. And we need that in order to stay in orbit. We also have an adjustable high-gain antenna system that's always pointed at the Earth to take the measurements we make and send them back to Earth so that they can be analyzed by the scientists on the mission.
And that can send a lot of data back with this one right here,
An
right?
awful lot of data, much more than any planetary mission has ever returned before.
Okay, so how about if I say I'm building my map of the moon and you explain how you're doing it, all right? So the first thing I'm going to want with the map is I'm going to want pictures. I'm going to want images of the moon.
That's right.
All right,
That's
so what on LRO is going to be able to do that?
Right. We have a camera system called the LRO camera, or LROC. It has 2 very high resolution cameras, so objects that are the size of this table or this big can be detected.
Or maybe a lunar rover, for example?
A lunar rover, we expect that when we go over the Apollo sites, we'll be able to image the lunar module, the lunar rovers, see the tracks the astronauts left as they disturb the surface.
So now we sort of have some images, but I want to know kind of in 3 dimensions what this looks like. What am I looking at for sure? Is it a hill or is it a valley?
That's right. What we lack now is a accurate topographic map of the moon. With LRO, we have a laser altimeter system. So every second we'll have 140 spots deposited on the surface. It'll measure the return with this system and then measure the distance to the surface, the roughness of the surface, and by looking at the 5 spots together, we'll know the tilt of the surface.
Those are 2 sort of basic, tangible ones, but you're going to want to know temperatures. I think that's a big deal on the moon, right?
Yes, because the moon goes through large temperature variations, unlike the Earth, where our atmosphere redistributes the temperature variations so that we don't have large temperature variations like you do on the moon. Also, some places on the moon we think are shadowed from sunlight, so they get very cold. So we want to measure temperatures around the moon. To do that, we have this instrument at the top called the Diviner experiment. By looking at the day-night variations, we can understand what the surface properties are and understand parameters like rock abundance, whether it's smooth, hard soil or whether it's rubbly like gravel, a surface texture that you cannot see with the imager even at 50 centimeters.
Right, so a sandy area when it goes from day to night will change temperature differently than a rocky area when it goes from day to night.
The heating and cooling runs at different rates depending on the surface characteristics.
Interesting.
We also have a UV spectrometer called LAMP, and this instrument will use starlight to image the dark regions where the sun doesn't shine, and by looking at the reflectivity of the starlight in ultraviolet, it can tell whether there's water frost on the surface or not.
That kind of does a lot of the mapping. Is there anything in particular, can you talk about the one we missed, that's kind of a more unique type of camera?
We have here at the bottom this large instrument, which is a neutron detector. It's called LEND, for Lunar Exploration Neutron Detector, and it's being supplied by Russia. And in regions where we think there is water, the hydrogen associated with the water will cause the neutron flux to decrease. So LEND will search for these regions where there's decreased neutron flux in order to measure hydrogen abundance.
So we're missing one big one, this whole big brown thing
Right.
right here. Can you explain to me what that is?
Yeah, that one was added late in the mission, and what it is an advanced radar system. What this system will do will send radio waves to the surface and measure the reflection of the surface in radio waves, and it uses several techniques to see if there's the signature, first of all, of surface roughness, and then also to see if there's some unique signatures associated with buried water ice on the lunar surface.
All right, well, thank you very much for showing this to me. We'll look forward to seeing what it starts sending back once we get it in
We're
orbit.
ready to go and enthusiastic to look at the data.